So today we start about chain rule. We also chain rule for measure. We also discuss today. Okay. In previous class we also proved this chain rule. Today we discuss chain rule for measure. Okay. We know about that. Here this X a algebra mu be a measure space. Okay, be a measure space. Then what happened? Then we also if some define some function if x2 r plus be a measurable function. Okay, be a measurable function, and then we also define this gamma e equal to integration of e if d mu. Okay, then obviously be a measure. Okay, now we'll also write this chain rule. Okay, chain rule for measure. Let mu, gamma and lambda, okay, be the measures on a measurable space. Be the measures on a measurable space. Okay, x descriptive such that, okay, such that first one, this gamma absolutely continuous with respect to mu with respect to lambda, and second one, okay, mu and lambda be sigma finite. Okay, then what happened? Then d of gamma by d lambda equal to d gamma by d mu equal to d mu by d lambda. Okay, this one be the chain rule for measure. Here mu, gamma, lambda be measures on a measurable space x algebra E, and such that this gamma is absolutely continuous with respect to mu, and mu is absolutely continuous with respect to lambda, and second, mu and lambda be sigma finite. So then what happened? Then d gamma of d lambda, or d of d lambda of gamma equal to d gamma of d mu and d mu by d lambda, or d of d mu of gamma and d of d lambda of mu. This one is the the chain rule for measure theory. We also discussed in previous class, so not a problem at all. Just mu and lambda be sigma finite. Okay, and obviously here gamma, mu and lambda all are obviously, that means gamma is absolutely continuous with respect to mu, and mu is absolutely continuous with respect to lambda. Then this one is happen. Okay, then we now going to further discussion of that. Okay, so that means we also proved this chain rule in previous class. So today we discuss one corollary related to this chain rule. Okay, we erase that portion and going to further discussion of that. Okay, so related corollary of chain rule. Now write this one corollary. Okay, corollary for chain rule. Let mu and gamma be measures on a measurable space. Be measures on a measurable space X descriptive such that first one is gamma absolutely continuous with respect to mu and mu absolutely continuous with respect to gamma, and 2 here gamma and mu are sigma finite. Okay, are sigma finite. Then what happened? Then obviously d gamma by d mu. Okay, d gamma by d mu multiplied d mu by d gamma equal to 1. Okay, we also write this one, and now we prove this one. Okay, so mu and gamma are measures on a measurable space X given A such that this gamma is absolutely continuous with respect to mu and mu is absolutely continuous with respect to gamma, and gamma and mu are sigma finite. Then d gamma by d mu and d mu by d gamma equal to 1. Okay, so we now prove that corollary related to chain rule in measure. Okay, so we write it now. Proof. We know that. Okay, we know that if mu lambda and gamma measures are measures, okay, on a measurable space on a measurable space this takes a cube. Okay, such that first this gamma is absolutely continuous with respect to mu and mu is absolutely continuous with respect to gamma. Okay, then what happened? Then obviously this gamma equal to we write this one. Okay, this one equal to lambda with talk about that. And then okay, and this one lambda equal to gamma and mu are sigma finite. Okay, then what happened? Then we erase our portion. Then by above theorem. Okay, then by above theorem, that means related to chain rule or for measure related to chain rule for measure. Okay, we get what we get: d gamma by d mu equal to d mu multiplied by d mu by d lambda equal to here d gamma by d lambda. Okay, then this one equal to, if we take lambda equal to gamma, then what happened? Then obviously we write it this one, d of gamma by d mu. Okay, here d mu by d gamma equal to d gamma by d gamma equal to 1. Okay, then we also do it too easily. That means just write the statement of this chain rule, and here we put, okay, we put this one. So d gamma by d mu, here d mu by d gamma equal to 1. Okay, okay, now we erase that portion and going to further discussion of that essential bounded function. Okay, here we write essential bounded function. Okay, essential bounded function, we write it now. Let x, this algebra mu, be a measure space, be a measure space, and E belongs to this algebra. Okay, then what happened? Then a measurable function if, then a measurable function if is said to be essentially bounded, is said to be essentially or essential bounded function, essential bounded function. Okay, a measurable function f is said to be essential bounded function if there exists a constant m greater than 0 such that mod of f less than equal to m. Okay, mu almost everywhere on u. And then what happened? Then mu of x belongs to e. Okay, if x greater than m equal to 0. Okay, that means measure of those set which satisfies fx greater than m, obviously 0. Okay, then we talk about that this measurable function is essential bounded function. Okay, that means this f is bounded almost everywhere on e. Okay, then what happened? Then this f equal to infimum of m greater than equal to 0 such that mod f less than equal to m, mu almost everywhere on p. Okay, then then this will call the essential bound of f. This will be called essential bound of f. Okay, so we also discuss when one function is essential bounded. Okay, and where we also discuss chain rule, that means statement of this chain rule for measure and obviously related corollary of this chain rule for measure. Okay, now we going to one important theorem related to this, that means related to this measure theory. Okay, we also discuss it now. So we erase that portion and going to further discussion of that. Okay, now we write this theorem here. Okay, let P belongs to 1 plus infinity with conjugate Q, with conjugate Q, let X this script A mu be a measure space. Okay, be a measure space and LPX equal to, here LPX is script A mu. Okay, be a Banach space with a norm, be a Banach space with norm, norm f equal to, okay, integration of x mod f whole to the power p d mu whole to the power 1 by p. Okay, where f belongs to L3x. Then what happened? Then let g belongs to LQX. Okay, and define TLPX to K by, okay, TF equal to integration of x fg dmu. Okay, for all f belongs to LPX. Then what happened? Okay, then first, then a T be a bounded linear functional, T be a bounded linear functional, and B norm of T equal to norm of C. Okay, so we now prove that portion. Okay, we just write this theorem. Here P belongs to 1 infinity with conjugate Q and X, this algebra mu be a measure space and LPX equal to LPX algebra mu be a Banach space with norm f equal to x mod f p d mu whole to the power 1 by p. F belongs to LPX and G belongs to LQX are defined T LPX to K by TF equal to integration of x fg d mu. For all f belongs to LPX, and then t is bounded linear functional and norm of t equal to norm of g. Okay, so we erase that portion and going to further discussion of that. So we have right now linearity of t. Okay, let f1 f2 belongs to lpx. Let f1 f2 belongs to lpx and alpha belongs to k, and alpha belongs to k. Okay, then what happened? Then t of f1 plus f2 equal to integration of x f1 plus f2 g d mu. Okay, then what happened? This one integration with respect to g f1 g d mu plus integration with respect to x f2 g d mu. Okay, then this one equal to tf1 plus tf2. Okay, then what happened? Then here we write about that t of alpha f1 equal to integration of x alpha f1 g d mu equal to here alpha common x f1 g d mu. Okay, equal to what? Equal to alpha t of f1. Okay, hence here t is additive, tv additive, and here tv homogeneous. Okay, homogeneous. Hence what happened? Hence t is a linear function. Okay, or erase that portion, that means linearity of t is done. Okay, now we're going to further discussion of that boundedness of t. Okay, linearity of t is done, then boundedness of t. Hence we write it now. Hence t be a linear function. Linear function. Okay. Now we're going to boundedness of t. Boundedness of t. Okay. Note that mod of t f equal to integration of f c d mu. Okay. Less than equal to integration of x mod of f c d mu. Less than equal to mod of gq here mod of f p for all f belongs to LPX. Okay, then what happened? Then obviously this one holds by holders inequality. Okay, by holders inequality. Then what happened? Then we write it now. Norm of Tx equal to less than equal to m norm x. Okay, this one, if this one hold, then we talk about that norm t less than equal to m. Okay, hence in this way, hence t be bounded with norm t less than equal to norm g. Okay, therefore t is a bounded linear functional. Therefore t is a bounded linear functional. Okay, now we write, that means we're going to next step. Okay, we also do it. That means t is bounded linear functional. Now we're going to norm of t equal to norm of c. This one we have to prove. We erase that portion and going to second part of this proof. Okay, this one too easy, but we do it. Okay, we have to do it. So option B, we tried it now, and going to here, note that norm of t less than equal to norm of c marked as star. Okay, and hence it's remain to show that, hence it remains to show that norm of g less than equal to norm of t. Okay, now we know that norm of t equal to supremum of f belongs to LPX mod of TF. Okay, here norm of f equal to 1. Then we now construct this one. We now construct f0 belongs to LPX such that norm of f0 equal to 1. Okay, then without loss of generality we do it. Then without loss of generality, okay, we may assume that norm of c not equal to 0. Define what happened. Define f equal to mod of g whole to the power q minus 1 is g and g. Okay, then what happened? Then integration of x mod of f whole to the power p d mu equal to integration of x mod of g whole to the power q minus 1 whole to the power p is g and g whole to the power p d mu. Okay, equal to integration of x g to the power q d mu and less than plus infinity. Okay, here q minus 1 p equal to q. Okay, so this was is done. Then what happened? Then hence obviously we erase that portion and going to discussion about that. Hence f is p integrable and f belongs to this one. Okay, we erase that portion and going to further discussion of that. Hence f b p integrable, that is f belongs to lpx. Okay, again norm f equal to integration of x mod of f p d mu whole to the power 1 by p equal to integration of x mod of g q d mu whole to the power 1 by p equal to norm of g whole to the power q by p equal to norm of g whole to the power q minus 1. Okay, then what happened? Now we write here define f0 equal to f by norm of g whole to the power q minus 1. Okay, f equal to what? F equal to mod of g whole to the power q minus 1 sgn g. Okay, by mod of g whole to the power q minus 1. So what happened? So note that then norm of f0 equal to 1. Okay, and now we're going to write about that norm of t equal to supremum of f belongs to lpx. Okay, and here norm f equal to 1 mod of tf greater than equal to tf0 equal to integration of mod of integration of x here g to the power q minus 1 is gn of g. Okay, by norm g to the power q minus 1 here g d mu. Okay, g d mu, this one more. Then what happened? Okay, then we also talk about that just f0 equal to this one, f equal to this by norm of g whole to the power q minus 1. Then norm of f0 equal to 1 and norm of t equal to this one. Okay, so now we're going to further discussion of that. Then what happened? This equal to integration of x here c to the power q by norm of c to the power q minus 1 d mu. Okay, mod of this. Then since we write it now, g is g and g equal to mod of g. Okay, then what happened? Then this one equal to 1 by norm z whole to the power q minus 1. Okay, integration of x mod z whole to the power q d mu. Okay, then this one would equal to what? Then 1 by norm z whole to the power q minus 1. Okay, multiplied by this to the power q equal to norm z. Okay, hence from 1 and 2, hence we mark this one is 2. Okay, that means hence norm t greater than equal to norm z, and we mark is double star. So from star and double star we get norm of t equal to norm of z. Okay, so today we stop here. If you get this type of video, please subscribe my channel. Okay, and if you gives like, please rest like, and obviously please click on like options. And now, and if you have some questions, suggestions and comments, please write it in comment box. So I think all are understand this one. Okay, so today I stop here.